Alright, hello, my name is Nicholas Dorfman, and this is my CD Nozzle project. And so, to start off, I made a CD Nozzle with my area inlets, or the length of my inlets being at 15 millimeters, my throat is at 10, my exit is at 20, with the length of about 75 millimeters. So first, we made sure that we do our solver as density based, since this is going to be a compressible flow. We made sure that our energy equation is on, and viscid flow, double checking. And we also made sure that our fluid is an ideal gas. And then so for our boundary conditions, we made sure that we type as a pressure inlets, just like our outlets. And so for our inlet, we made sure we do 3 bars, or 30,000 kilopascals, apply. And so for our outlet, we also made sure that there was 0 gauge pressure here, since this is fully isentropic flow. And then click. Make sure you do standard initialization. Click inlet, initialize. Give it about 10 seconds for it to do the calculations. Alright, and just like that, we're done. So, for over here in our graphs, under contours, we have 6 contours, 1 for pressure, velocity, density, speed of sound, Mach number, and temperature. But just to show, here's our pressure. Yeah, static pressure. And then here's going to be our velocity, which should be the exact opposite, which makes sense since they're inversely proportional. This is our density. Density looks just like our pressure, since pressure and density are proportional. And so our interesting one here is temperature. So obviously velocity and temperature are inversely proportional, so we got that. But we also have over here, which is our speed of sound, which looks relatively the same as temperature, since temperature is the only variable, only independent variable in this, besides, gamma and I. Also for plots, we were able to create a line in the center line. You go here, you click new surface, line, and then you just put in the things. And then since when I made it symmetric off the x-axis. All you have to do is mess with the x-axis coordinates, so you create the center line. And then here are all 6 of our plots. So velocity, and here's our temperature. Now, so for the second part of the project, where we have to make a normal shock into the inside, we have to increase our back pressure a little bit. So after a bunch of trials, I found that 30,600 as our gauge pressure, given also a little bit of calculations as well to help me out. Click apply, close, hit initialize, inlets, and then let's run our calculation. Give it another 10 seconds. Alright, perfect. So, as you can see from let's open up our pressure contours, we have something interesting over here. So, this red obviously shows the higher pressure as it goes through, then it turns to blue since it's moving obviously at supersonic. And now we have this wall that shows the normal shock. And after the shock, we have a pressure that is still not as low as the supersonic, and not as high since before the throat, where it was moving very slow. And also to double check this as well, and open up our XY plots, you can see over here where our significantly starts to go down to about right over here, which is where our throat is. Then tries to go a little faster and faster, and it goes to our Mach number. Now at this point, this is where our normal shock is, and since at the normal shock, obviously the flow significantly decreased, we have a spike in pressure. Now to double check that as well, we can also look at our XY plot from the center line for velocity, and we see how it's really slow here before the throat, and as it goes towards the throat, it goes faster and faster. It continues to go even faster as it goes into the normal shock, and a complete decrease in velocity as we get there. And then here's at the exit. So there's my project, and I hope you enjoy.